This time, I'm going to talk about neural networks with Python. Neural networks are based on a collection of connected units. Sometimes we call those connected units neurons. Those neurons, just like the synapses in a brain, can transmit a signal to other neurons, so that acting like interconnected brain cells, then can learn and make decisions in a more human-like manner. Usually, a neural network have input layer and output layer. We have signal input from input layer, and eventually we will get output from output layer. In the middle, we have hidden layers. That means the signal input from input layer will be processed in those hidden layers, and eventually we will calculate the signal, the output in output layer. You might heard the term neural network and deep learning. So what's the difference? Usually we have hidden layers in the neural network. If we have at least 2 hidden layers, we call it deep learning. Let's clarify the relationships among artificial intelligence, machine learning, neural networks, and deep learning. Machine learning is a subfield of artificial intelligence, and deep learning is a subfield of machine learning, and neural network is in between. So this is like if you talk about artificial intelligence, that's very broad area, and inside that area we have machine learning, and inside that one methodology is called neural networks. And as I mentioned, if you have at least 2 hidden layers in your neural networks, and then it will become deep learning. A big advantage with deep learning, and a key part in understanding why it's becoming popular, is that it's powered by massive amounts of data. Let's take a look at this graph. The y-axis shows the performance, and the x-axis shows amount of data. When we have a small data set, and you can see the neural network and the deep neural network, they don't have much difference. And also, when you have very limited amount of data, and even comparing with the traditional machine learning, they're almost the same. But when you have large amount of data, you can see deep neural network or deep learning perform much better than neural network, and neural network perform much better than the traditional machine learning. As you know, nowadays the data amount keep increasing tremendously, so that's why deep learning become very popular. We compare the neural network and deep learning. Now let's compare traditional machine learning and deep learning. Let's take a look at this chart. We have input and we want to produce output. In this process, we need to extract features from our data, and then we need to perform classification. In regular machine learning, usually a person or expert will extract all those features, and then we feed the data to a model to perform classification. But when we use deep learning, our model will extract features and perform classification by itself. There are no human intervention during this process. So, our model in deep learning is behaving more intelligent, just like a human. There is one important concept called activation function. First, we have input, and we need to process all the data with our model and produce output. In this process, we will put weight for each input and then feed into this transfer function, produce one net input for this activation function. This activation function has a threshold. If the value fed in this activation function is over our threshold, and then it is activated and produce a final output here. If it's below the threshold, and then it is not activated, that's why it is called activation function. There are many types of activation functions we usually use. Here, let me give you two examples. First one is called ReLU function. This function works like this. If the input value to this activation function is less than 0, or it is negative, then the output will be 0. But if the input to this activation function is positive, then it will have the same value output from this activation function. For example, if the input is 1, the output will be 1. And the input is 2, and output will be 2. But again, if the input value is negative, for example, -1, then the output value will be 0. Another activation function is called logistic sigmoid function. And this activation function is usually used for credit risk. For example, when a customer is applying for a mortgage, if we say the output, if it's 1, that means we will approve his or her application. If the output is 0, we just deny his or her application. And then, based on this customer's credit score or his credit history, we will have all those input. And no matter how good the customer's credit score is, we cannot guarantee 100% this customer will get this mortgage approved. So this is not a linear function. Just saying you have a better credit score or better credit history, you are most likely to get your mortgage approved, but not 100% guaranteed. And same logic, even the customer has bad credit score or bad credit history, and that customer still have a small chance to get this mortgage approved. This is activation function usually used for the credit risk management. Now let's go to Python to see how can we build deep learning model with Python. In Python, there is a package called TensorFlow. The package TensorFlow can help us build neural network model. First, let's build a very simple model. This model will have only 3 inputs and 1 output, and the activation function is linear. Let's build this model. You can see there are only 4 parameters in this model because we only have 3 inputs and 1 output. This kind of model only has 1 input layer and 1 output layer. This kind of neural network is called perceptron. Now, let's build a more complicated model. This time, we are going to have 2 hidden layers, and we will have input layer and output layer. You can see the parameters increased a lot. For the first hidden layer, we have 66 parameters, and the second one will have 21 parameters, and the output will have 4 parameters. If we visualize this network, it will look like this. In this model, we have input layer, output layer, and 2 hidden layers. As I mentioned before, if you have 2 or more hidden layers, we can consider the model as a deep learning model. Also, in this model, I used dropout technique. This dropout technique is dropping input randomly in order to avoid overfitting for the model. So, there are 10 input features, and then it will go to the 6 neurons in the hidden layer 1. After the dropout technique, it will fit into hidden layer 2, which has 3 neurons. And again, we use dropout technique again, and eventually we will get our output. In deep learning model, you don't have to use same activation functions for all the layers. In this model, we use ReLU activation function for hidden layer 1 and hidden layer 2, but we use sigmoid activation function for the output. You can see with the package TensorFlow in Python, we can build our deep learning model easily. I will upload this source code to GitHub so you can play around with it by yourself. In this video, I only showed you how to build neural networks or deep learning model with Python. In the next video, I'm going to show you how to train your model and how to validate your model. Please provide your comments and subscribe to my YouTube channel. Thank you for watching.